Hello, my name is Steven. Welcome to Hyfindr Tech Talks, where it is our goal to understand the technology in the hydrogen economy. Today, we are going to talk about tanks. Not anyone's, but Type 3 tanks. And with me is someone who has 30 years of experience in the forging industry, has worked very widely, very internationally as well. He's from AST near LA, connected directly to us. Welcome, Sigi Rivalta.
Hello, Stephen, and hello, everyone at the organization. It's a pleasure meeting you. I'm looking forward to a good conversation regarding tanks, COPVs for various of industries.
Okay, Sigi, I already see you're coming up with the abbreviations, your deep insight. So please bear with us as we walk this line with you. So let's start with the real basics. What types of tanks are there at all in this industry? Maybe you can help us to kick us off into that.
Sure, we're glad to be. So there is 5 different tanks that are today widely used in this market. The type 1 is the type is a steel tank or a metal tank with steel or aluminum, used frequently for firefighter tanks, for scuba diving, and for industrial gases. The type 2 tank is a tank that is a steel tank and has a glass or carbon fiber winding around, but only in the cylindrical section. So it is not a fully wrapped tank, it's only a partly wrapped cylinder that is used for different gases and at higher pressures also. The type number 3 is a type with aluminum liners. The aluminum liner is mainly then bound with carbon fiber, with high strength carbon fiber, and is one of the tanks that has the best filling rates we will see later on. Type number 4 is a composite tank with carbon fiber. In other words, it is a liner that is made out of plastic or thermoplastic, and the rest is pretty much the same as a type 3 when it comes to carbon fiber winding. Type 5 is a liner-less cylinder, so it has no liners. There's only 2 on the ends, 2 connections. They are made out of aluminum bound into the cylinder.
Okay, so those are the different types, and so that means essentially type 1 is all metal up to the other end. Type 5 is almost all composite. Or did I get this correctly?
All composite, correct.
Okay, so
the lightest, the type 5 is pretty much still in development, being used in very isolated situations. It's a tank that's super light and therefore will come in the space area. But widely used today at type 1, 3, and 4. When 1 is the heaviest tank because it's a steel, and when it comes to high pressure, the walls are very thick. Therefore, it's a heavy tank, and the type 4 is the lightest tank in the market.
Okay, maybe just a very basic. So why these? Who came up with these numbers? why do we even have this number? Why isn't the type 2 type 1? Or is it because they were developed after each other?
Yeah, the business, the COPV started pretty much with type 1s, and then as they developed over years, and the pressures went higher, they went up then to different types of applications. When weight is very significant or very important, then the type 1 was not a good application for, especially in the aerospace area, and everything, well, let's say everything that flies needs to be light.
Yeah. Okay, thanks for this overview. So Sigi, I know you come from the world of type 3. Can you take us a little bit deeper into that type of tank and show us what's going on in that area?
Of course. So what you see on this slide, the type 1 is a fully metal tank. So you have metal inside, metal outside. It's pretty straightforward. The type number 2, you can see now the tanks from the inside. That means it's metal inside, aluminum or steel. But on type 3, it is clearly visible that you have an aluminum liner. And the aluminum liner is a one-piece liner. So it is a one-piece forged, flow-formed, and closed liner. So it's not welded, has not any weldings or any gaps between the two ends. So then the type 4 tank has the PVC liner and has an insert of aluminum. You see the PVC there in color, and then on the right side and on the left side, you see the aluminum connections. The reason for that is you cannot connect a valve with high pressure into the PVC or to HDPE liner. It has to be metal to metal. So they have a metal insert. In other words, it is not a one-piece liner.
Okay.
So then the type 5 has no liner at all, as you can see on the inside.
Okay. And regarding the type 3, just also in comparison to the others in terms of operation and so on?
Yeah, the type 3 has the big advantage. Aluminum is a very high conductive material and has therefore a lot of dissipation of heat during the filling process. And I'm going to show you a little bit what's happened during filling in another slide. So the high thermal conductivity really sucks in the heat during the filling process. And therefore we get more gas in the tank, and getting more gas in the tank is a bigger range, a larger range for the truck or wherever it's mounted. The metal liner does not buckle like a plastic liner, so we can completely empty the liner as well. We don't have to leave any gas in, so to avoid the buckling of the liner. In other words, with tests we have made, long-term tests, we have compared type 3 with type 4 doing the fast filling rate, and the fast filling capacity on a type 3 is up to almost 100%, when the type 4 is below that, to 70-75%.
You mentioned that the specific advantage is during the refilling process also. Is this correct?
The defilling process, yes. The defilling process, the benefits are that the tank can be completely emptied. So we don't have to leave pressure inside in order to maintain the liner in this position.
Understood.
It's metal.
Yeah, but you mentioned earlier that, in terms of when you are filling the tank, that the type 3 have a particular difference in comparison to the composites when the gas is going in.
This is the main benefit right now in the type 3. When you see the filling rate here, this is a CNG application. It's a tank with 250 bar, should fill to 20 gallon gasoline gallon equivalent. And when you see the fill rate on the left side on the station, this filling, during the filling process, the molecules start to colliding each other at a very high speed. At the beginning, the temperature goes down, as you can see in the middle graph below, and then the temperature starts fast to rise as the pressure goes up. So you can see on the left, below on the left graph, that at 4,100 psi, which is about 285 bars, the station shuts off for safety reason. And then on the right graph, you can see you have not reached 100% fill. So what's happened now, when you see the bottom graph, the temperature starts going down. So it's cooling off slowly, and then I can refill if I have to on the type 4. But on the type 3, I don't have that because that heat is getting into the liner.
Okay.
So therefore, the molecules, when they heat up and the heat goes into the liner, I can get a better fill. The heat is not trapped in the tank.
Okay, so I think that's a considerable advantage. But I think it must be hard to manufacture or to make these aluminum shapes and all these composites. Can you say how you do that?
Yeah, so it's a different process than having made a liner out of a tube. So by forging the tube, we are getting different. We get very large diameters, which is our focus to get diameters over the dimension that you normally buy in extruded pipes. Therefore, we start with the forging, as you can see on the left slide. The forging is more like a dish, and then we start spin forming after that, and flow forming made out of tube of aluminum stock of 6061. So we start with the 61 tube, 61 billet, and go into the tube shape at the end. There, the next pass is then closing the tube at the ends. Afterward, they are heat treated to T6 conditions, and the machining at the ends that you can see here, the machine on the outside is to mount the mounting blocks for the cylinders. So that's an outside machining, and the inside machining is to mount the valves.
So that is a neck mount you have there. So
this is the neck mount. There is also in some applications strut mounts. The neck mount is a very clean mounting. It is easy to inspect. It's also not touching the carbon fiber, which is a significant benefit versus the strut mounting.
Okay, understood.
Further on, we go to wrap the cylinder. So we do carbon fiber wrapping with, we use a wet process. There's wet and dry. The dry process is with pre-pack fiber. We use the wet process, which is probably the one most used in the market. And then we do the testing at the end. Every cylinder before it leaves the factory is tested 100%, which is the out-of-attach and the hydro testing.
Okay.
The out-of-attach testing lays the aluminum into the carbon fiber. The carbon fiber has a very low elongation. It's about 2 to 3%. When the aluminum has elongation, the 6061 between 12 and up to 16, 18% in different cases. So therefore, the aluminum is stretched into the carbon fiber under high pressure. And then the hydro test brings it back to the original form. And there, the liner will cycle between those two areas for his cycle life of 15 years in case of the hydrogen cylinders for high pressure.
Sorry, I need to ask, can you say that again? So the tank is actually expanded, and the fiber brings it back into shape, or did I get this wrong?
So yeah, the tank, the liner is expanded into the wall of the carbon fiber.
The liner inside.
Carbon fiber has a very low elongation, but the liner let it expand itself into the wall, and from there, doing afterwards the hydro test, which is at lower pressure, between those two areas, the cylinder is going to cycle for his life.
Okay, understood. Okay.
Doing filling and unfilling or the defilling.
Okay, and when you wrap that around the tank, just out of estimate, how long is the liner that you put? Like, is this, like, I always imagine that there's supposed to be endless, let me say, miles of tape that goes around there.
Yeah, so it pretty much depends on the pressure. More pressure, more carbon fiber binding.
Yeah.
The aluminum or the liner is pretty much only a container for the gas. What gives us the integrity of the cylinder itself is the carbon fiber.
Okay.
So the higher the pressure, the more fiber we get on those tanks. And you can see in this one here, the carbon fiber thickness is much more than the aluminum thickness on the wall.
Yes.
So the pressure is really depending how much fiber we have to wind on. How long does it take? Yeah, it depends on the equipment. There is very sophisticated equipment that has a better output, a higher rate. I would say for a cylinder, it depends on the size also. On average, it's about an hour. There's multiple spindle machines available that can do more than one tank at the same time. So it depends on the equipment.
Wow. Okay, but I mean, an hour is, I think, is pretty good for such a big tank, considering the diameters you do. So, also considering the diameters you do, where can we even find these kind of products in the hydrogen economy in total?
Yeah, it goes. It goes for different application, mainly for storage and transport, where we focus our product rather than doing it on port. So it depends on the weight. Also, on-board storage tanks are very weight sensitive. When transportation is a better fit for the trees, because they are getting charged very fast. They need to be discharged completely in order to get the benefits, really not carrying gas around back to the stations. So that's one of the main reasons right now that type 3s are used for that transportation in gases form. We also have some fleet operations. There's different applications where we use those type 3s in order to bring the molecule to the customer, since the infrastructure is very, very weak still in the US as it is in Europe and other countries. We don't have enough stations, nor do we have pipelines to bring the hydrogen to the customer. So therefore, we have to track it pretty much with those racks and trailers.
Okay, well, yeah, I mean, things will surely develop, but Sigi, I need to ask you one more thing. So the thing is that when I worked on a project at a time, we also had the topic of a tank. And I mean, it was one thing to find a tank, and the other thing was, did it have the right certification? And, actually that seemed to be even kind of the bigger hurdle to getting the actual vessel. So can you tell us a little bit about that? I mean, since Type 3 have been around for a while, I would estimate that is, can one say it's taken care of?
Yeah, the certification, luckily now is more going towards the international certifications, leaning on the ISO specs. We used to have this difference on the CNG side. Luckily now on hydrogen, it is becoming more an international certification. So we still have to go to this DOT or ISO DOT certification. Every country has a different certification, like Europe, but they're all lean on the basics from the ISO. So that's a very good trend.
So you do the certification yourselves, or you have how?
We have to have a third party that needs to monitor our operation. It is a certification first that goes to a process of testing, a very long process where the DOT is involved from the beginning, and then also doing production. The DOT is present in our facility.
Okay, as you mentioned that certification is getting more and more international, are there perhaps any other trends in the Type 3 type tank that you can share with us, developments that you are seeing from your end?
Yeah, the ports are one of the areas that are leading up here this effort in the United States, at least, and in California. California has multiple ports that are changing their transportation system to clean energy, which is started with natural gas and is moving now to battery and hydrogen electric. So those areas are really aggressively trying to get the ports clean by 2035, and therefore we're doing some very nice projects with forklift operators, and they converted to hydrogen electric, and there's different backup applications also, and charging application with hydrogen fuel cells. Those are the main areas that we're focusing on right now.
Yeah, okay, wonderful to see that these things are also getting inbuilt into those kinds of vehicles. And yeah, these are some good outlooks. So, Sigi, unfortunately, the time has flown through just as much as we passed through the whole stages of the Type 3 tank. Thank you very much for sharing these really interesting insights and for dialing in with us all the way from the Los Angeles area where you are located. The good news is people can get in contact with you and find out more about these kinds of storage options. When they go on Hyfindr, they can find your products there, just as they can find some other fitting products for this as well to build the hydrogen economy, which we are all engaged in. Thank you very much, dear Sigi, for this time, and thank you to all those who watched for your time. It's been an absolute pleasure. If you liked it, please give us a like or subscribe to our channel. It's been an absolute pleasure. Thank you again, Sigi, and we hope that you come back to make another video with us sometime. And to the viewers, please feel free to watch any other videos. Thank you very much. All the best.
Thank you, Stephen. I appreciate it. And definitely we are, as a small company, very flexible, and we make our own liners, so we are welcome to do also customized products. Contact us or contact Hyfindr. Thank you very much for this interview.
Perfect. Thank you so much. Bye.